are going to be fortunate enough to be interviewing Dr. Robert Langer. Dr. Langer is a professor at MIT and has been called the Edison of medicine.
Along with this, he's also the founder of Moderna.
Moderna is a company working on delivering the much-anticipated COVID-19 vaccine. Dr. Langer is an amazing scientist, and by doing this interview, we hope to learn lots from him. So now, let us have Dr. Langer take the stage. Hello, Dr. Langer.
We are really excited to speak with you today. I am Leon.
And I'm Chamonix. You are called the Edison of our times. You have come up with so many inventions. Inventing one thing is so difficult. And you've done it 1,400 times.
We read that you have 1,400 patents.
And in addition, you've started 30 plus companies based on these patents. We really want to know how you do it.
So let's get started.
That sounds great. You guys are great interviewers. So I'll be happy to. So ask me any questions you want.
You have so many inventions to your name. How do you come up with these ideas?
Well, sometimes, all different ways. One is so, sometimes I let people in my laboratory together and I have like an area that I think we want to create, like creating new biodegradable materials that'll be better for people. We brainstorm and we put things on the blackboard and so forth. Other times, I've just gotten ideas from watching a TV show or listening to music or reading a magazine, and it kind of comes out of the blue. One of the things, though, that I think has helped me is that I got my degrees in engineering, and then I worked in a hospital, and I was actually the only engineer in the hospital. So by being in the hospital, what was very good for me is I was able to put the engineering ideas together with the medicine. So I thought differently than like the regular doctors or the regular engineers because I knew a little bit about both those things.
So once you have come up with an invention, how do you decide whether to start a company with it or not?
Yeah, well, I don't think we want to start a company too soon. And I think we really want to make sure that the invention's a transformative invention, something that can be used for a lot of things. So if the invention is something that could be used, like an example is we started this company you may have heard of called Moderna, and they're making the COVID vaccine. But they actually also can use the same technology to make 9 other vaccines and also to treat different diseases, including cancer and heart disease. So when enough progress has been made in the laboratory and you have good patents and you feel it can be used for many things, then we might start a company. But usually it takes a good deal of work even before we start the company, before we actually do that.
You have founded over 30 companies based on your inventions. Is there a fixed process to turn inventions into companies?
I don't think so, but there are some things that are important. In the biomedical area, one of the things that's important is getting a good patent. That I think is very important. And of course, you need to get very good people. But I'd say beyond that, there is no, I've seen companies start all kinds of ways.
Yeah. You are regarded as the founder of tissue engineering in regenerative medicine. Can you tell us what it is and how it is applied today?
Yes. Well, what tissue engineering involves is trying to make a new tissue really from scratch. And often it involves taking cells and materials and putting them together in such a way that they could make a new tissue. An example is new skin if somebody got burned, which is actually being used today. And then people are trying to make new blood vessels and so forth. And then they're even making tissues on a chip, like a heart on a chip and things like that, so that you could, do drug testing better without using animals or people as much. And some people are even using it to make meat, for example. It's early. It's that's being studied. It's not out in the market yet, but maybe will be sometime.
So if your heart stops, you can replace it with another heart you've grown?
Well, maybe someday. We can't do that now, but someday I bet you will be able to do it.
So does that mean in the future we can grow limbs if we were to lose them in an accident, sort of like how a lizard grows its tail?
Again, I don't think we can't do that today, but maybe someday we can as we understand the science better.
What do most people not realize about vaccines?
They may not realize how much work it is to actually create them and do the science behind it. It's a very, it takes a lot of research, a lot of time, a lot of effort, and a lot of money.
What does mRNA do? Why is it important?
Well, there's a dogma that you may have heard of, maybe not, but it's that DNA makes RNA, makes proteins. So if you gave RNA, you can make any proteins. So that's actually been a very good thing. So if you give RNA to a person, it will make proteins, and that protein could help make a vaccine. It could help make a new drug or something else. So it's very important, because if you try to just make the proteins, that might take you a year. They may be impure. They couldn't go into cells, whereas the RNA can do all. You just give a little bit of RNA, and then you have your own body as a factory to make the proteins.
So a software program tells a computer what to do. Is mRNA a bit like that, and does it tell the body to make antigens by itself?
Yes, that's excellent on your part. Absolutely correct what you just said.
The mRNA approach to vaccines helps speed up the vaccine production because you don't need very much of the original virus. Are there any other benefits to mRNA?
Yes, I mean, that's excellent what you said. Another benefit is for intracellular. There's some diseases, like maybe what are called enzyme deficiency diseases. They're often rare diseases, but they're very bad. They're inside a cell. And with RNA, you can get inside the cell and possibly cure them.
Are there any cons of an mRNA approach?
I don't think there are any cons, but, it's a brand new technology. So, there's a lot of development work being done on it.
How does the medicine, when you inject it, how does it tell your body to make the virus, the antigens?
Yeah, it doesn't tell the body to make the virus, but what it does is when you give the RNA, let's say you're dealing with COVID, which you hear about. So what it does is it makes it's like you make the RNA against what's called the spike protein. That's a particular part of the virus, and so it basically makes something, and you need that spike protein to get into the cells. In other words, the COVID virus won't be successful if it can't get into the cell, and so you can actually stop it by making and even maybe destroy it by making antibodies against what's called the spike protein.
You are the founder of Moderna, and what we know about Moderna is that it is working on developing a vaccine for the much dreaded coronavirus. But what exactly is Moderna's goal?
Well, I think Moderna's goal, again, everybody may say slightly different things, but Moderna is broadly developing RNA therapies. As I mentioned, that's a new kind of therapy which I think could be revolutionary. And certainly the COVID example that we're talking about is a great example of what it can do. But it can do, I think, much more. I think it's a whole new class of medicines that really can change the face of medicine, because it's a better way, it's potentially a better way of making vaccines. It can treat intracellular diseases, and do a lot of things that you could never do before. But this is all potential. But there's something like 14 clinical trials going on now for different things. So it's moving pretty fast.
What happened to the company after the vaccine's created?
Well, the company's still going. First, the company has to keep producing the vaccine, and it has to but people may need that vaccine for many years. But that's, like I say, Moderna's working on many vaccines and many different drug products. So the company keeps working on all these different things, new medicines that can treat many, many different diseases.
You are a pioneer of many technologies, including the Transdermal Delivery systems. So, can you explain what this is?
Well, Transdermal Delivery Systems is a patch that has medicine in it, and you put it on the skin, and then the drug diffuses through the skin into the body. So it's a very convenient way of giving medicine.
Does this mean I will never have to get an injection? I hate needles.
Well, I think it depends on the substance. I think we are working on ways to get rid of needles too, but I would say that it will mean that for many drugs you won't need needles, but there's still some drugs you may, at least at this point. But people like ourselves, we're working on ways of getting rid of needles by using what are called microneedles, which you won't really feel, and also ultrasound and things like that. So I think there's a lot of interesting work going on in that area.
We have a question from 8-year-old Arjun, who lives in Dallas.
Hi, I'm Arjun. I am 10 years old and I have type 1 diabetes. I use an insulin pump and the site changes are really hard. Is there any other way I can get insulin?
Yes, we're working on some of those things. I'll tell you a couple of ways that we're working on that, but they're still experimental. Way one is we've come up with a pill that you can take. I'll even show it to you. That you can swallow, and then it goes in the stomach and it makes an injection. And this is actually the pill. I'll just show it here. Can you see it?
Yeah.
So this is the pill, and that's one way.
Yeah.
So you swallow it, and it just goes in and injects the insulin in the stomach. The second the way we're looking at it is we're trying to make what's called an artificial pancreas. So we can take what are called beta cells, those are the insulin-producing cells, and put them in little capsules that you can inject just once. And then hopefully they'll last for 6 months to a year, if not longer.
What are citations and why are they important?
Well, citations are people writing an article and talking about your work in it. So they cite a paper we do. They're important because I think it shows that people are reading your work and they're looking at your work. So I guess it's important because it helps people do things they might not have been able to do before.
When did you know that you would become an inventor? What inspired you?
Well, I didn't really think about inventing. I just thought about how could I do things that might help people and using science to do this. But then, when you do science and you make a discovery, well, I realized and my advisor realized that, we could write a patent and that might be useful, for moving that discovery forward.
And when did you know you wanted to be an entrepreneur?
Well, about the same time, because I tried to get large companies to use my inventions, but they move very slowly. So I realized that if I was going to make this happen, I better do it myself.
Yes. Do you think there were some certain experiences during your childhood or young adulthood that helped build the foundation for your future career?
Yes. When I was a child, my parents gave me these sets, like this Gilbert chemistry set where you could mix chemicals, and I liked that, and they would change color. And then there was a microscope set where you could watch shrimp eggs hatch. So that was good. And then later in my career, I as I mentioned, I worked in a hospital, and that gave me a lot of ideas. And my advisor was a really great person, and I think that also helped me a lot.
Could you tell us a little bit about your childhood?
Yeah, it was actually a pretty normal childhood. I played sports like baseball and football, and I went to a public school. It was 3 blocks away, and I was it was pretty normal. My dad and my mom were, my dad ran a small business, a little liquor store, and my mom she took care of me and my sister.
Did you like playing pranks when you were growing up?
Somewhat, yeah. I would, especially on my sister.
Yeah, except it's the other way around. He tries pranks and fails. Nah.
Right.
Did you have any pets?
I didn't when I was growing up. Later on, I had a very nice dog named Neptune.
What breed is Neptune?
He was a shepherd husky.
Oh,
He was very, very pretty, handsome dog.
do you still have him?
No, I actually got an allergy, but then my sister, but he had him for many years, and then he went to live with my sister, but he's passed away. But that was a while back.
Did you ask your parents to get the dog, Neptune?
I didn't. They really weren't big fans of dogs, so later on, I got a dog. When I was more when I was grown up, but I think the dog was wonderful. I mean, he was a great dog, very affectionate, smart. It was a great, wonderful dog. I loved him.
Do you have any advice on how to convince parents to get their kids pets?
Well, I can tell you, our children. I guess the thing is taking care of the dog. The dog. The problem I think parents are usually worried about is the children want the dog, but then the parents have to do all the work. So, I don't know if there's some way to get somebody else to do the work other than the parents, but that might help. And, the dog has to be house trained and stuff like that.
Yes. What were some of your hobbies growing up?
Well, magic. I've always loved magic. That's been one of my hobbies, and sports also.
Do you have any magic tricks which you can distinctly remember?
Oh, sure. All kinds of card tricks. I have card tricks. Lots of different tricks I've done. Card tricks where, you think of I have you pick a card and put it back in the deck, and I find it. I have all kinds of tricks.
We know how to do some magic ourselves. Yeah. So basically, don't tell everyone. This is gonna be posted. It's like, magicians don't tell their secrets, and here you are.
We might take a video of us doing the magic. After this video.
Sounds good.
Do you have any book recommendations for children our age?
Well, when I was young, I read, and I don't know that they still have them, but there were these series called Tom Swift, and they were very good books. Like he had like a submarine, a spaceship, but this was when I was a kid. But I think there are lots of books like Tom Sawyer, Huckleberry Finn. I mean, but there are lots of very good books that I remember reading when I was young.
Yes.
But I really like the Tom Swift books. That was also probably inspiring to me scientifically.
Do you or have you heard of any computer games?
Well, I'm not an expert at computer games, so it's a good question. So I'm probably not the best expert to answer that. But there is one called Tetris, I guess, that I used to play. It's got... I don't know. Yeah, that may have other names, but it was like shooting different things. But I think it's called Tetris.
My brother and I love to play Minecraft, and we think it's a really good game. Have you heard of it?
I don't know that one, but that sounds interesting.
So, for some strange and crazy reason, parents are completely against Minecraft and every other single video game.
Parents can be funny sometimes. They're different, but I know. But I'm a parent too.
Were you naughty as a child?
Well, I certainly wasn't perfect all the time. So, I wasn't probably always so nice to my sister. So,
yeah! No! Yes! He said he wasn't so nice to his sister. Leon? Yes, you are really so nice to your sister! So,
What were some of your favorite subjects in school?
Well, my favorite subjects in school were math and science, I guess, really, like chemistry. Yeah, I guess those were the main ones.
Which teachers had the most influence on you?
Well, my second grade teacher was, she really encouraged me. My sixth grade teacher was very good. She encouraged me also. My second grade teacher encouraged me in math, my sixth grade teacher in science.
What do you do to relax or have fun after a tiring day?
Well, sometimes I exercise, but not after a tiring day. I spend time with my wife. I sometimes watch TV shows. I read, different things like that. I eat.
You sleep.
I definitely do that.
What do you wish you knew when you were our age?
Well, I guess I wish I knew the future, but it's hard to know. I mean, I think just, trying to, that's a great question. I'm not really sure. I've even found like the things that I didn't know, I learned through going through the process. So I don't know that I'd want to necessarily give that up.
We have a question from 11-year-old Orlando who lives in London. He asks,
what will be the most interesting areas of science when I'm older?
Well, I think biology is very interesting. I think material science and chemical engineering are very interesting. Bioengineering is very interesting. So I think there are a lot. I mean, science is just never ending. There's just so many things you can do.
what advice do you have for young inventors, young scientists, and young entrepreneurs of the future?
Well, just to do it. I think that, well, first, I think it's really good to learn things in school, learn the fundamentals. And then I think it's great to invent things. I think that's exciting. So you just do it.
So, thank you so much for being here with us today, Dr. Langer. We really appreciate it.
Well, thank you. You asked wonderful, wonderful questions. It's a pleasure to speak to two such smart young people.
Thank you.
Thank you.
We just finished interviewing Dr. Robert Langer. He is such an inspiration, and it's so cool to be talking to someone who is part of working for the vaccine for COVID-19. I'm pretty sure every single buddy in the whole wide world really wants COVID to be done with. So I'm really looking forward to what Dr. Langer is doing, and I really hope that the vaccine comes out soon. See you later!